Yeah, I'm the community manager for Pravega. Like LitmusChaos, Pravega is a sandbox project at the CNCF. And like we said previously, we've been using LitmusChaos, I think, for about a year in our internal testing to ensure that the streaming data platform that we're building on top of Pravega is resilient. Pravega is a streaming storage engine, very similar to Pulsar or Kafka, but we're sort of focused on being a storage system first. So our semantics for streams are slightly different than other message buses, but in general, we provide message bus like semantics. Although we can also store byte streams like like live streams, or we have a GStreamer plugins, so you can actually store multimedia, continuous multimedia on Pravega. So we have, I guess, also some additional use cases that other message buses don't provide, as our emphasis on storage. We're a project coming out of Dell EMC, which is a big enterprise storage company, and in our experience with other messaging systems, we found that we needed to develop something new to meet all of our use cases, to simplify development, to simplify administration, and so forth. So that's kind of the goal of Pravega and the orientation of it. And we're in the process of, I guess, opening up the tools that Somesh will show in our use of LitmusChaos, so that we can educate our community as to how to use LitmusChaos themselves, in their productizations of Pravega. So I guess that's my introduction.
Thanks a lot, Derek. I think that was awesome, and looking forward to more collaboration in the community. And folks, feel free to ask any questions related to Pravega as well to Derek, Somesh, Manoj, and I think Sheetal has also joined. So if you have any questions related to that, so without any further delay, I'll allow Somesh to take it forward from here, talking about chaos use cases with LitmusChaos at Pravega. Thank you.
Hello everyone. For briefing out all related stuff to the community. So as said, I'll be the team on behalf of the FI test cases execution, the fault injection scenarios that we perform on our product Pravega to identify the failure behaviors of our system when we introduce the common or the expected failure scenarios over a Kubernetes system, as a product is deployed on the same environment. So basically, I'll start with the Litmus setup introduction. So I'll start with sharing my screen here. Yeah. So the setup is very simple. It's a 4-step process. First, we install the Litmus operator here. Then we go with the chaos experiments. And with this, we get the functionality to use chaos experiments through running the chaos engine here. And finally, we have some integrations available from the chaos side to examine our fault test over the system based on its result output. And we do have certain cross validations, which I'll be showing in the demo, how we validate on our end also that the expected fault which we wanted to introduce over the system took place in the right manner. And so the initial step, as I mentioned, we go with just the Litmus operator installation, which is as simple as running a kubectl command with the corresponding image for which we desire to install the Litmus operator here. As we deploy the Litmus, as we run this command, we should see certain resources getting deployed on our system parallelly. So as this process gets successful, we tend to see a Litmus operator pod in the same cluster where we desire to inject our faults via LitmusChaos, and certain custom resources that would be that we would be using in our experiments will also be available there. I'll just show my cluster where the same versions, the same resources we can uh, cross check. So this is the cluster. As I mentioned, certain resources that will be seen after the Litmus operator successful installation. Here we see a pod in Litmus namespace, the LitmusChaos operator pod, and these are the CRDs which can be checked uh, upon uh, a successful installation of the operator, enabling us with this resources, the Kubernetes resources that we get here. So the next step would be, once the operator is installed, we go with the experiments installation, which gives us the tools or the actual experiments that we want to perform. The faults that we want to induce in our cluster are all available after we the Litmus experiment here, like common scenarios of pod network losses, pod network latency losses, and CPU hog, such common fault injection experiments we get here. And this process is also quite simple. We have to install with the right manifest to the same version that will be for the same um, um, qualification. We need to install the corresponding experiment manifest, and the same resources gets installed here. Uh, we can see here in the cluster in like I have already installed the chaos experiment. So this is the list of chaos experiments that we'll be getting in turn. Right after that uh, comes the action part, running the chaos engine. So here we start the chaos engine for a desired chaos experiment. One at a time will be going, like for example, I am choosing here pod network loss fault injection scenario for my cluster. So I have to go with the installation of its respective service account, which will enable us to perform the network loss scenario over the cluster. And then we get something like this here in that cluster. So this is the pod network loss service account that I had installed, and we can see the same is running here. With this, we can go with the chaos engine manifest, where we get all sorts of parameter that are useful um, to describe how is the experiment, the fault injection test is going to run over our system, like which is the target container here, on which we desire to inject the fault, how long the chaos is going to take place over the same resource, and its useful image, or the exact uh, engine that we'll be using here. So one of the important parameter, how much percentage of network loss we want to see getting injected over our targeted resource. So these are the few parameters that we have to specify in order for the chaos to take place as we expect. So this is the manifest that I'm using here for the system, where as seen in the wiki, I have mentioned the target container as Pravega segment store. This is the segment store component of our Pravega distributed system, where I'm targeting instance segment store 0 here with its respective image, the engine image, and I'm selecting I'm configuring here the network loss percentage as 30% and chaos duration as just 300 seconds, or a 5 minutes of fault all totally. And with this, we'll just start injecting the fault over our system. So this is our cluster here, and as mentioned, I'm targeting this through these two pods here for injecting the pod loss fault. So basically what happens here when we inject this fault, we expect to see some packet losses happening whenever there is a connection being made, and data is been exchanged over this component. So at present, since I haven't started the chaos engine and things are just at the normal level, if we could just ping the same pod here, like if you see, uh, these two pods have their internal IPs as 17 and 19 ending here. The same IPs, if I try to ping, I see here there's almost or absolute no packet loss here. So all the packets that were transmitted got received successfully when like as expected. I haven't started the chaos, so things are normal, just validating before injecting the chaos to the system. So both the pods are in healthy state with no packet losses. And I have a background IO running here, which uh, is uh, um, continuously writing and reading um, around 10 kbps of record per second events. That is the workload being generated here. So we have our dashboard to monitor the same. And as we see here, there's the live event injection and read rate here, 10.5 kbps over our Pravega stream. So this is just a sample workload. We can see there is a uniform behavior here in the IO, and there's no disruption as possibly seen here. So things are these all are the background verifications we do before starting the chaos in order to check how the cluster behaves when we introduce the fault, and are we able to recover from the same failure or not if such a thing happens in a live system. So this is a simple script here which I'll be using to introduce the chaos for both the available segments to instances consecutively. So this is the script I'm running here. So I have started the chaos engine as I mentioned here in the wiki. Like if we are ready with the operator and the chaos experiments been installed, we are ready to inject the faults. Hence, I've started the chaos engine here, and it has started for both the segments to instances that we have deployed in the cluster. So we can see here the chaos runner pods been deployed here successfully on the cluster, which in turn installs the chaos pods for 2 pods each for the targeted instance. So we have all totally 4 plus 2 6 pods here additionally installed as we start the engine. And now if we check how uh, is the same component responding when we introduce a 30% of network loss here, we can see so exactly we see here 30% of packet losses taking place for the same component. That means 7 out of 10 packets are only received at the send. That means there are packets been blocked by the LitmusChaos tool here before reaching to this component. And same goes with the other instance. It could be plus minus 10 when we introduce the chaos. So it's in the expected range here, 40%. And if you see the IO, it was earlier in a uniform 10 kbps flow, but now there are some disruptions happening as the fault has been introduced over the system. So this total chaos as mentioned and shown is just for 5 minutes or 300 seconds. So we expect the same fault to be running for 5 minutes and continuously seeing the same behavior from the segment stored pods here. Like 30% of packet loss being experienced by these components. Nearly, so 40 here. Simultaneously, if we check the IO, since we see there is some packet loss there happening, so even the IO gets affected during the chaos. There are some ups and downs graphs that we can see on the metrics, some spikes. So almost half the period is over. So we have a fourth step to explain here, which was after we introduce the faults, we have certain utilities from the chaos which we can validate to see how has our fault injection test completed over the system. Like uh, if all the parameters match uh, as expected, the status will get updated as completed with pass result. And if something unusual happens or things goes unexpected, the status would change to fail here. So I'll just show the same resources here. If we do check, so since I introduced it for two pod instances, so there are two result resources being running here. If I describe each, the status here, it shows us the chaos is still in the running mode, and the final result is yet to be updated, as it depends on the overall period over which the fault is introduced. So one of them has completed now, so both has completed, and we can see slowly uh, the pods that were installed by the chaos engine are changing its status to the task completion state. And now if we check here, the IO seems to be resumed uh, to its expected state of uniformity. How about the packet loss behavior from the same instances where we had seen uh, some loss earlier? So it is free from any of the packet losses now, as it was previously. Yeah, so it seems the process of introducing the fault here has gracefully completed. um, with as the chaos period gets over, we see the component has come back to its original state of no packet loss or healthy state, which is very important whenever we run any fault injection mechanism over our cluster. uh, After the fault period is over, it is very important for the same instance to get freed from the chaos that was injected earlier. So now we can check what does the chaos result tells us. Yeah, since everything has completed in the graceful manner, uh, so the final result is also updated as pass, and we get the pass message here. That was for first instance. Similarly, for the second instance, if we see, we are getting the same here. That means both have passed successfully, both tests, and the system has recovered after the fault period got over. So just for a cross check on the metric side also, we can see yeah, the normal state is recovered again. So we are getting what we were seeing previously. There is things in the stable state here. So these are the four parts of chaos through Litmus, and this is how we validate it. on our systems using the same chaos utilities and some of our additional uh, validation points. I'm done with the demo here. So any doubts, please come up now.
Thanks a lot, Somesh. Do we have any questions for Somesh?
Maybe one question from the sake of the community. So when we run this, I could say that you are running this test for a pretty long period, like that it's 1,000 seconds or so. So did
300
we
seconds.
encounter any faults which helped to fix in your product running this chaos?
Yeah, like in the initial stages of bringing stability to the product, I think we had used the standards there, like do it now for 5 minutes, and have improved ourselves testing or validating on the same grounds.
Thank you. And one more question on top of that. Other than network loss, what other tests do you cover?
We do run the pod network latency experiment here, sometimes CPU hog, and also adapting soon on the automation side, so that we get the privilege of use chaos experiments also that the chaos tool provides.
Thanks so much.
Thanks, Ajit.
Thanks a lot, Somesh. I think this was good, and thanks a lot for presenting. And we look forward to the review from the Pravega team on 2.0 whenever they get started. So that will be great.
Sure, Prithvi. Thank you. Thank you for allowing me to do this.